So I do some ACT help for people. I have for quite a while. And when we get ready for the ACT, one of the biggest things we got to do is memorize some formulas, because the ACT does not give you a formulas list. There's a lot of like big tests out there that do, like the SAT does, but most of you guys aren't going to take the SAT. Most of you guys, if you're going to take one, you're going to take the ACT. And the ACT doesn't give you formulas. So here's one. Let's see if you remember it. X equals b, not x equals negative b. Sorry, that's a different one. Negative b over 2a. Do you remember what that goes with?
Vertex.
The vertex one. Good. So if I asked you, what's the vertex on this? You could use that formula. But you got to know what b is. Well, I think by now it's kind of duh. B is negative 3. Did you get that? Okay. What's a in this one? There's no number where a is. So what is it? 1. For a while, it's real common for people to think that it's 1x. No, it's just the 1. B is just the negative 3, and C is just the negative 4. Okay. Then what's that other gigantor formula? X equals negative b plus or minus. What's that thing called? Square root of b squared minus 4ac all over 2a. And that's called the what formula? Quadratic. Now, when they ask you, what time did the ball hit the ground? Do you remember those problems? What time did the ball hit the ground? That's that formula. So if you're drawing it, it would look like this. You see this? I'm going to make it black. See this black spot right here? That's the moment that the ball hit the ground, and this formula tells you the x. Remember how I said it was the x-intercept? So when they say, when did the ball hit the ground? Use this formula. Okay, so now you know you're supposed to use that formula. But what if they tell you that the height was like 6? Well, then the problem would look like this. It would have an f of x in the front of it. And if they say the height is supposed to be 6, f of x is the height. You would put it right here. So now, what's A, B, and C? Hint, you don't know until you move the 6 over. If I want the height to be 6, I put the 6 there. But I got to subtract 6 from both sides. And then I'd have 0 equals x squared minus 3x minus 10. Do you get that now I have a quadratic that I can use the quadratic formula on to tell when the ball got there? Okay. Yes? So they'll give you a number like height is 6. Okay. If they tell you that the height is, here's one that where it's confusing for a lot of people, like, when did the ball hit the ground? And then people are like, but they didn't tell me the height. The ball hit the ground. So what's the height when the ball's hitting the ground? 0. Okay, so that was the biggest problem last night is people had an equation like this. Everybody write this one down. Negative 16t squared plus 3t plus 4. And I think the easy questions weren't that bad. They were like, so how fast did he throw the ball? Do you guys know which of these 3 things is how fast he threw the ball? That one. Maybe you should write it down, because that's one of the things I taught you yesterday. That's called the velocity. Which of these 3 things tells you how high you were off the ground when you threw the ball?
4.
That one. So this is the start height. When you start the problem, that's the start height. This is the blue one is the velocity, how fast you threw the ball. And over here, this one, height. So what if they tell you the height is like 10? You replace this with a 10. What if they tell you that the height was the ball hit the ground? Well, then it's 0. Zero's the easiest kind because then you don't have to like redo your equation. You just have it already set equal to 0, and that's exactly the way you want it. So then what do you do with this? Well, there's really only one thing you can do. You can use the quadratic formula. So the quadratic formula tells you that spot, when the ball hit the ground. Now, if they change that to, instead of when did the ball hit the ground, when did the ball hit 8 feet, what number would I change if I wanted to do 8 feet off the ground instead of ball hits the ground? Where should the 8 feet go? There's really only 2 spots. Do you think that the time is 8? No. So then this must be 8. If they want you to see when the height was 8, you'd put the 8 there. Because was f of x, that's where the height is. And then you could use the quadratic formula again to solve it, but you can't just use a, b, and c and ignore the 8 over there. You'd have to start by subtracting 8. Okay. So when you have an equation that has, I'm going to back up here. It looks like this, where you've got a height here and a time here. If they tell you the time, put it in where t is. If you tell you the height, put it where the height was. All right, so I'm going to do one with you, and I'm going to see if you've got it now. Everybody, write this one down. We're going to call it problem A. H of t equals negative 16 t squared plus 10t plus 2. Now this whole formula is in feet. So if I ever talk about a height, it's in feet. If I talk about a velocity, it's in feet per second. What if I asked you for height is 0? When would the ball be at height 0? Well, if you look at the picture of the ball, do you get it would be at height 0 at that exact moment, and that's the moment the ball hit the ground. So if I tell you height 0, there's only one place you could put it in the equation. Go ahead and do it. Put it in the right spot. And then just tell me what you would put in the calculator. I know it's too complicated to actually put in. It'll take too much time, but what would you put in where? All right, Ian, height is 0. Where do I put it?
In place of 2?
Nope, because that's the starting height. And this is not that. This is when we started, that's this 2, that's right here.
Oh, for t.
Okay, t is the time. If the height is 0, did I say that the time was 0? No, it's not that either. Most of you are like only looking at things that are over here. Like, where could I put it in there? Nope, you're not putting it in there. Do you know? Where does it go? H of t. Right there. That becomes 0. Okay, there's your height of 0. You put it where h of t is. Now we can use the quadratic formula. Negative what? 10 plus or minus the square root of b squared, which would be what? What's b squared? You can do it in your head. Yep. Minus 4 times a. What's a? Yep. Times c. Yep. So I'm replacing c with a 2 here. All over to a, which is 2 times, what's a again? And that will tell us X is time. That'll tell us the time when the ball hit the ground. Now, another thing I got a lot of questions about last night was, but I get two answers. Okay, if you get two answers and one of them is negative, negative time doesn't exist. If I say that happened at time -4, there's no such thing. Okay, so if you get two answers and one of them is negative, you just get to throw it out. Do you get we would have two answers because it has a plus and a minus here? You're gonna get two answers. You just have to be smart enough to go, okay, the negative ones get thrown out because there's no such thing as negative time. And all the rest of this is just you having to type numbers into a calculator. All right, so what were the steps again? If they give you a height, you put it here. Since this one was equal to 0, this was super easy. I knew A was this, I knew B was this, and I knew C was this. What if instead of 0, they had said the height is 10? Well, and that means they want you to look, here, let's look at the picture here. They want height of 10, that's like this. They want to know when did the ball go over that height. So you're going to have two answers again, and this makes more sense this time because you'll have one height where it went above 10, and then later on, it went back past 10 again. If you think of it as like a wire that was 10 feet high, and the ball goes above that wire and then comes back down. So there was twice. But if I'm supposed to put in height of 10, where would you put it? I blame myself. I did not teach you this well enough. The height goes here. That's the height. So if they tell me it's 10, then I got to put a 10 there. But do you get A, B, and C aren't all going to just stay the same because there's a 10 over here now? How do I get the 10 out of there? Subtract 10. Do you get how this number will change then when I subtract 10 from both sides? So now I'm going to write that out. 10 equals -16t squared plus 10t plus 2. Because this is a height of 10 now, instead of a 0, you have one extra step, and that is you subtract 10 from both sides. And then you can do the quadratic formula. And that is all set up for the quadratic formula now. Okay, so the one I wish I would have spent more time on last night was, what if they give you a height of, and you stick it right there, and then you have to subtract it from both sides to get it set back to 0, because quadratics always have to be set to 0. All right, one last thing. Let's take the same exact equation, and instead of a height, let's say if they don't mess with the height, then they maybe will mess with the time. What if I say, where is the ball at time 1? Please tell me you were thinking of putting it in where the t was. Doesn't that make sense? If time is 1, you're going to put it here. And again, a calculator can do this, but you could even do it in your head because it's a 1. 1 squared is 1. 1 times -16 is -16. Plus a 10. Plus a 2. That's not that hard. You can do that in your head. All right, so here's one like that. This is question B. Everybody write this down. H of t equals -16t squared plus 8t plus 1. How far off the ground are we when we start this problem? 1. That's what that number at the end is. It's how far off the ground you are when you start. Carl, do you know what the 8's for?
No.
Anybody know what the 8's for? Velocity. This as in the speed you threw it at. Velocity is 8. This is the starting height So if you're throwing it off the ground, you get it. For me, my starting height would be like 5 feet off the ground. So I'd be like this one. I'd be letting the ball go, be over my head. I'm not more like 6 feet tall, but maybe this would be like 6 feet, something like 6 feet-ish. Okay? So then as soon as I let go of the ball, that's the start of the problem. What if I want it to go to height 7? Do you know where to put that? Yeah, the 7 would go here. Yeah, what if instead of that, I wanted to know where is it at time 1 second? You can do this in your head. Everybody figure out where the ball would be at time 1 second. I didn't tell you the height. I told you the time. So the good news is that this is the last new thing I needed to teach you. And we have a review day today. And then we review this stuff again on Monday. No, Tuesday. You don't have school Monday. We review it again on Tuesday. And then you have a quiz on this stuff. Well, it's a test, actually. It's just your test for this unit. Happens on Wednesday. And that's your last normal test. Then Thursday and Friday are review days for the final. Monday and Tuesday are review days for the final. And then Tuesday you won't have a final in my class. And the last day of the semester for you guys is that Wednesday.
What's our final?
That's the final. Wednesday. What is the final on? The final is on everything from this whole semester, this whole year. So everything you've learned this year. That's what it is for most high school classes. All right, so if you're going to put in 1 second, it doesn't take a genius here to have figured out by now that's the height. That's the time. You should have put the T where the 1 is and the 1 where the T is. Okay, there's only 2 things you can put in, time or height. Those 2 things. Okay, this one would be negative 16. This one would be 8. What's negative 16 plus 8? It's negative 8. Plus 1, it's negative 7. That's weird. At time 1 second, the ball would be at a negative height. That actually could happen. It's like you threw the ball up. You were on top of this little cliff that's up 1 foot off the ground. You throw it up, and 1 second later, it's underground, so to speak. I know, ball would have, if a normal world, ball would have bounced right there and would have stopped. But this is kind of like it's mud or something, and it just keeps going down into the mud. All right, so the formula for that is the quadratic formula. The formula for that is negative b over 2a. And there's only one more formula. And that's the discriminant. The discriminant is actually this. And it tells how many solutions. What if it comes out positive? How many solutions will we have? 2. What if it comes out negative? How many solutions will we have? We won't have any, right. And what if it comes out to 0? Then you have 1 solution. Because if this whole thing is 0, do you get it's like it won't even exist? But there's an answer right here still. And it's the vertex. Okay, so there's a little review. I'm going to give you 3 questions to sum it up and before we head off to lunch here. And let's see if you can answer these questions. Number 1, if I give you this quadratic, would you please tell me the discriminant and how many solutions it has? Number two, if I give you this equation, what's the starting height? What's the velocity? Question 3, if I wanted to know when the ball hits six feet. You were 5 feet up when you threw it, so you definitely would, the ball would definitely hit 6 feet. What would you do? You got to use the red equation, of course. We're going to go through these before we head off to lunch. So, Carl, discriminant for number 1. What's discriminant mean? It's one of those little formulas, remember it?
Oh,
It's part of the gigantic formula. It's the part underneath the root.
B squared minus 4 times A times C.
You got it. And in this case, let's put in the B, A, and the C. So, Carl, what's the B?
-9.
Yep. And then, what's the A?
1.
And what's the C?
-10.
Good. If you guys can multiply that out, you'll have it. How many solutions? Well, I can tell you this, Ian. It's going to be a big positive number. So how many solutions will I have? If the discriminant comes out positive.
I did not finish the equation.
All right, let's finish this. That comes out to 81 plus 40, which is 121. Does that tell you how many solutions I should have?
2.
Yes.
Square negative, it's positive.
That becomes positive 81. And there's 2 negatives here and here, which makes that positive 40. So 81 plus 40 makes 121. We're going soon. Just give me a second. The starting height here is 5. The velocity is 3. How many of you had that right? Awesome. We'll finish the rest after lunch. Okay, here we go. We're back from lunch. So the last part, if I wanted to know when the ball hits 6 feet, I go back into this height formula right here, and I go, where is the only place it's logical to put height of 6 feet? Well, you can't put it in under time. That wouldn't make any sense. Height. So right there, you put a 6. So you put the 6 right there. And then you can use the quadratic formula, but not right away. Why can't you use the quadratic formula with A, B, and C? Because the C is going to be different. That number is going to change because you're going to subtract 6 from both sides. I can do that really small right here, minus 6, and then this side is 0. And then minus 6 over here, what is 5 minus 6 going to turn into? -1, very good. Then I can use the quadratic formula with a is -16, and b is 3, and c is -1. And that's how you would figure out the answer to that question. So if they give you a height, put it over under h of t. If they give you a time, put it under t. Okay, cool. I feel like you're ready. So there is a worksheet in today's folder. I'm going to pause for a second while we find that together. Okay, we found the worksheet. It wasn't published, and I thought I was going to print it, but anyway, it's finally done. Is the first question square root of 40? Okay, so let's do that together. Square root of 40. Well, you break it into two square roots. Square root of 4 and square root of 10. And remember, it's times. So then what is the square root of 4? 2. So it's 2 square roots of 10. That's the end of that one. Jackson, can you read me number 2? I'll come back to you in a second. Grace, can you read me number 2? Is this a square root of something?
Square root of 45.
45. Then I'd go with, well, how about you tell me? Can you,
Square root of 9, square root of 5.
that's it. And then square root of 9 is actually
3 square root
3 square roots of
of 5.
5 is the final answer. It's making sense? All right. If you want to hit the bathroom now that you started on it, then I'm good with that. Okay, on to number 3. Amelia, can you read us number 3?
5 square root of 20.
Can't this just be done? No, because the square root of 20 could actually be broken up into two things. Ian, can you tell us what those two things are?
5 and 4.
Square root of 5, square root of 4. And one of those two works out perfect. Max, can you put this along with this and tell me the final answer?
25.
Close. You have to do the square root of the 4 first.
2.
There we go.
10.
10 root 5, that's it. Nice. Okay. Then let's jump to one of the harder ones. Avia, would you look up one of the ones that's different and harder?
Yeah.
Savannah, you have a question in the meantime? You seem like
Just explain what you were doing there.
right there. Yep. Do you get that the root 5 and the root 4 make the root 20? Okay, and all of these are being multiplied. Like this red 5 here is just a 5, and this is going to turn into a regular 2, and they're all being multiplied. So this 5 joins up with this square root of 4 here, which is really just 2, and 2 times the 5 makes 10, because they're all just being multiplied. So I rearranged them and did two things at once in my head, but maybe that was too much. That's why it's 10 root 5. Avia, have you found one of the harder ones that you want to ask about?
Well, should we do a discriminant and solution one?
Sure.
Or equation?
Read that one.
Okay. So, we can do
Problem number what?
5.
Number 5.
Negative x squared minus 3x plus 2 equals 0. Or is that easy one?
No, this is fine. This is good. Okay, so what do we want? Discriminant, and then how many solutions it has? Okay, discriminant's b squared minus 4ac. So let's do that. Megan, can you tell us what the b is in this case? Close. Negative 3. Negative 3 squared, 9, minus 4 times ac. Now, if you're going to mess up, I've always said that's this thing underneath the root that's the hardest, but it's actually the 4ac that's the hardest, because you're doing 3 things multiplied in a row. Usually 2 of them are negative. So the a here is -1, and the c here is 2. So right there, that's the hardest part of all of these, is the b squared minus 4ac, specifically the minus 4ac. So just be really careful in there. I got two negatives, which means I'm going to actually add it. And it's 4 times 1 times 2, which makes 8, added to the 9, 17. Very good. Now, that's the discriminant. If they ask what's the discriminant, that's it. But then you're supposed to be able to go, okay, so does that tell me? It's like reading the tea leaves, so to speak. That there were people in the old days that thought they could read the leaves from your tea and see what your future was. That's what the tea leaves reference is. But we're reading this, and in the future we'd say, oh, I can tell because it's positive, then I'm going to have two solutions. If it had come out negative, I would say there was no solutions. And the only other thing is, what else is there besides being positive or being a negative? There's something in between. Zero. And then there'd be one solution if there was 0. Can you remember that? Positive gives you 2. Negative doesn't give you any. But what's exactly between them? 0. And that gives you one solution. Okay. Now let's do 1, 2, skip a few and go to near the end, because last time a ton of people got stumped when they started giving you these quadratic equations that have like negative 16, t squared, whatever. So let's go further on in the worksheet and show me which part of it might kick your butt. Grace, do you have one?
Question 9.
Number 9. Would you read me the equation?
H t equals negative 16t squared
Yep.
plus 24t.
Okay, wait. Now I got to catch up. Minus 24t.
Plus 24t.
Oh, thank you. And then?
Plus 4.
Now, if you told me a t, I'd put it where the t is. If you told me a time. If you told me a height, I would put it there. If you told me it was gonna be on the ground, I would go, oh, so you mean the height is 0. And I'd put a height of 0. So which are they telling you?
It says the height of the football that is thrown upwards can be modified function.
That's good.
Okay, so here's our function. And they want to know the height.
What's the initial velocity of the ball? There's like 4 questions.
Oh, okay. What's the first question, Grace?
What is the initial velocity of the ball?
Oh, which of these 3 things is velocity?
24.
24 is the velocity. What's the second question?
What is the initial height of the ball?
And that is?
4 feet.
4 is correct. And what's the next question?
How high is the ball after 0.5 seconds?
All right, so did they just tell me the height or the time?
The time.
They just told you the time. So you're going to put that in the t. Now this, I can't just do this one for you. You have to use a calculator. It's going to take you a minute. You're going to put a 0.5 here, and you got to put a 0.5 there, and then you got to just crunch all of those numbers. It's going to take a little bit, but you and a calculator can get that. And then what's the last thing?
When does the ball hit the ground?
Oh, so then I can take the 0.5 out of there and go to a different one where I make the HT is, what's the height then? If it just hit the ground, what's the height? 0. So you say 0 equals this, and then what is that fancy formula called that solves this?
Quadratic.
The quadratic formula. So you just use the quadratic formula, and there's a 0 here now because we said it was hitting the ground. All right. There's a good review of everything. Most of the test is pretty easy, I think you'd say. It's just the scary part is at the end there where they start telling you like the heights and the times and stuff. And you just got to stick them in the equation and use the quadratic formula. Okay, that's all I got for you for today.